Okay, welcome to Trig lesson number 7, problem solving and the ambiguous case of the sine law. So what this section is gonna look like is you're gonna be given measurements for a triangle. And with these measurements, you're gonna be asked to construct the triangle and then to solve the triangle. And so there'll be some situations where you'll have a triangle that will have multiple solutions. And so we're gonna look at this first example and to see why would you have more than one solution for a triangle with certain measurements. So two students were asked to determine the measure of angle ACB in a triangle in which AB is equal to 6 centimeters, AC is equal to 4 centimeters, and angle ABC is equal to 30 degrees. So two students, Scott and Brittany, each constructed a triangle to represent the given information. So here's Scott's triangle, and here's Brittany's triangle. As you can tell, both these triangles look very different. Okay, like one's way bigger than the other one's a lot smaller. You can see that there's different angles involved in both of them. And so we want to see if both these students are correct, or if neither of them are correct. Alright, so the first thing we need to do is use a ruler and protractor to determine if the student's triangle correctly represent the given information. So let's look at Scott's triangle first. We're told that AB is supposed to be 6 centimeters, so if we measure AB, we get 6, which is good. And let's measure Brittany's side for AB is also 6. Okay, so they both have AB correctly set up. Now let's look at AC. AC is supposed to be 4 centimeters, and so Scott is good on 4 centimeters, and Brittany is good on 4 centimeters as well. Now let's take a look at angle ABC, which is angle B over here. Right? It's supposed to be 30 degrees. Good. So Scott's triangle is 30 degrees on angle ABC, and Brittany's is also on angle 30 degrees for angle B. And so yes, that answers our first question. Now the next thing we need to do is, without using a measuring device, estimate to the nearest 10 degrees the measure of angle ACB in each case. So they're looking for angle ACB, which for Scott's triangle is up here, and for Brittany's triangle is right here. Okay, so for each of these triangles, we want to see what that angle is. And you know what? Technically, both these triangles are set up correctly. And we know just from looking at these angles that they are going to have different answers. Scott's angle C is an acute angle, and Brittany's angle C is an obtuse angle. Okay, so right away we know that we are going to have different answers for angle ACB. And so we're asked to estimate without using a measuring device both of their triangles and both the angle C. So let's estimate to the nearest 10 degrees. Alright, so if I look at Scott's triangle up here at angle C, I know that that's less than 90 degrees, so I can't extend beyond 90 since it's an acute angle. It looks like it's a little bit more than 45 degrees to me. I'm just estimating again, and it's the nearest 10 degrees, so I'm just going to say it's 50 degrees. All right, now with Brittany's triangle, hers is an obtuse angle, and so it's over 90 degrees. All right, so this is the part of math where you kind of just need to use logic, right? A large part of math is using your logic and reasoning. And so let's look at estimating Brittany's angle C. Okay, so I'm just going to say that to me that looks like it's 120 degrees, and we'll see how close or how far off I am here. Okay, so we've taken a look at estimating each of those angles. We're going to move on to the next question, which is, in each case, use the sine law to determine the measure of angle ACB, so the one we just estimated, to the nearest degree. So let's set up Scott's triangle right now, and then use the sine law in order to solve. Okay, so if I'm using the sine law, then remember, if you take a look at your triangle again, I'll just move up here. If I take a look at my triangle, I have one side and I have two sides. So I have side C because it's across from angle C, and I have side B since it's across from angle B. And so this is side C and this is side B. And then I have a measurement of 30 degrees. So I have 3 pieces of information, and so that is enough in order to use my sine law. So the way I'm going to set this up is, since I don't have any information for angle A or side A, I'm going to use sine B over B is equal to sine C over C. Alright, so I know that sine B was sine 30 degrees, and I know that side B was 4 centimeters, and that was equal to sine C, which I don't know. C is my unknown, but side C was 6 centimeters. So the way this equation is going to look when I set it up is I'm going to cross multiply my top and bottom terms. Okay, so it's going to be 4 sine C is equal to 6 times the sine of 30. And now remember, I need to divide. I want to get this sine C by itself, so I'll have to divide by 4. So I divide by 4 on both sides. Okay, and so then sine C is going to equal 6 sine 30 divided by 4. Alright, and so if you bust out your calculator, then type this in, you should get an answer of 0.75. Okay, so 0.75, that is the ratio for sine C, and then you'll have to take the inverse of that. Okay, so the inverse of 0.75, type that into your calculator. That'll give you angle ACB, angle C that we're looking for, and that is going to be 49 degrees. Right? So, wow, look how close I was. 50 degrees, we're at 49 degrees. Now, let's look at Brittany over here. Okay, we're measuring to the nearest degree. So you actually, in your calculator, you didn't get 49 degrees exactly. We had to round up to 49 degrees because we always want to round to the nearest degree, remember, for angles. So you never want to have an angle of 48.657 or something like that, right? You always round up to the nearest angle, the nearest degree. Okay, so let's look at Brittany's. We're gonna have identical work to her situation because, again, we don't have anything for angle or for angle A or side A for Brittany's triangle. And so the way we actually set up her equation is going to look very similar. Okay, in fact, it's going to be identical. The work, it's going to be identical, and I'll show you why. Sine B is equal to sine C over C. Now let's look at what sine B is for Brittany. It's going to be sine 30 times, or sine 30 divided by 4, and that'll equal sine C divided by 6. All right, and that's exactly what we did with Scott's case. And so if you look at that, and I'll just set this up, sine 30 over 4 is equal to sine C over 6. You're going to say, well, like she's going to get the exact same answer then that Scott got. And the answer is yes and no. Because remember, we're solving for angle C. And so I'm going to skip that middle step there where we know we're just going to have to divide by 4 at the end. So what sine C is going to equal, it's identical to what we did over here. Sine C is going to equal 6 times sine 30. And we're going to divide that by 4. Since we multiplied it by 4 over here, we had to divide it out. And we also get 0.75. And we already solved that to be 49 degrees. Alright, so if we look at both these triangles, we just solved this to be 49 degrees. And and that makes sense, right? It's a lot less than 90 degrees. And it looks like it's a little bit more than 45 degrees. And so 49 degrees, that was our solution. But for Brittany's triangle, we're told that angle C is 49 degrees. But if we look at this angle, it's an obtuse angle. And so if we have an obtuse angle, this is where you really need to use your logic, and you have to look at these triangles and say, okay, this angle can certainly not be 49 degrees. And so what you then have to do is realize that this 49 degrees that's given to you is just the reference angle. So you have to kind of treat this like angle ACB is in quadrant 2. Okay, so what we have to do is we have to use our reference angles in order to solve what this 49 degrees actually means. Okay, so if 49 degrees is a reference angle, then we have to go 180 degrees minus 49 degrees. And that'll give us an answer of 131 degrees. Okay, and so that is our solution for Brittany's triangle. Okay, so this is what the ambiguous case of the sine law is you're given information and you use the same information. So we had 6 centimeters for a length of AB. We had 4 centimeters. I'll go back to my diagrams. We had 6 centimeters for AB on both these triangles. We had 4 centimeters for AC in both of our triangles. We had angle ABC, or angle B, equal to 30 degrees in both of them. But with that information, we are able to create 2 triangles that had 2 different solutions. And so this is the ambiguous case of the sine law. Okay? And this is what this lesson is going to be about. Okay, so what I did is I skipped ahead a few pages to page 200. Okay, so page 200 of the ambiguous case. And what I want to do is just look at some of the case studies that they have given to you in your workbook. Okay, so let's look at this first one, case number 1. Consider triangle ABC in which AB is equal to 6 centimeters and angle ABC is equal to 30 degrees. So we are going to consider 3 different measurements for AC and use the sine law to determine the measure of angle BAC. Okay, so let's take a look at what we need to do here. So let's look at case number 1 where AC, we're told, is equal to 2.5 centimeters. Alright, so AC is equal to 2.5 centimeters. And there's a typo here. They say AB is 6, but it's actually 3. Okay, so that's why you look down here, AB is 3. Okay, so everything else is the same. But what we need to do is, in each case, we have to look at what we have to make this measurement. Okay, so 2.5 centimeters. If I want to make this 2.5 centimeters, let's see, what is this triangle going to look like? I can make 2.5, let's see, 2.5 is going to be up here, it looks like. Okay, so in order to have a complete triangle, first thing that you need to do is extend this line. So when you're working with these questions, the best thing to do is extend the leg of the triangle that is opposite of your given length. Okay, so this is my given length, and this is the length that's opposite. The reason I'm going to do that is, as you'll see, I didn't know where to draw this 2.5 centimeters, right? Because I didn't know where to connect it to this other side, and so I had to draw this other side first. Okay, so we want it to be 2.5 centimeters, and 2.5 is going to be about right there. Oh, that bled a lot. Okay, so 2.5 centimeters, but if I'm thinking about the sine law, there could potentially be more than one solution for this triangle. And so let's see if there's anywhere else I can fit 2.5 centimeters. And there is, and this is going to be a really tiny angle. And I'm going to do this one in blue, but yeah, this will be a really tiny angle if we take a look at that, right? So both of these are, I have two different triangles here. I have this one in red, and I have this one in blue. Both of them have lengths of 2.5 centimeters, which we were asked to make these lengths. Now, what we need to do is step 2. Use the sine law to determine sine C. Okay, so if I'm looking for sine C, then sine C is going to be right here. I'll call that C1, but it's also going to be down here at this angle, and I'll call that C2. Okay, and so we're looking for both of those. Now, if I'm looking for sine C, then I have two pieces of information for both my triangles. I have the length of C, I have a length of B, and I also have my angle B, which was 30 degrees. Okay, and so we can set this up in order to solve sine C in both cases. Okay, so let's look at this first one. Sine C over C is equal to sine B over B. Remember, sine C is our unknown, and we are dividing that by 3, which was side C. It's directly across from both of our angle C's. Sine B was 30 degrees, and we are going to divide that by 2.5. Okay, and so now in order to solve for sine C, that's going to become 3 times sine 30, since we're cross multiplying, and we'll divide that by 2.5, since 2.5 is actually over here. When we divide it over, it'll bring it under our first part of the equation. Now, we need to calculate, and I need to move my paper up. Okay, so this is this is 2.5. Now we need to calculate what this is going to be. Okay, so in your calculator, remember, make sure you are in degrees. Good, I'm in degrees. And then you can type in all this information. So 3 sine 30 divided by 2.5 give me 0.6. 0.6. And if we do the inverse of 0.6, we're going to get an answer of 36.8. But remember, this is not 36.8 because we need to round up. That is 37 degrees. And just like the question tells us, you are given a reference angle of 37 degrees, and solve for sine C was 0.6, and that's what we got down here. Good, that means we're on the right track. So now, if we know that angle C is 37 degrees, right? So this was 37 degrees. That's what it was telling us. This angle is 37 degrees. But we also, remember, have this tiny, well, actually it's a big angle on a tiny triangle. But if we take a look at our tiny triangle at C2, that was not 37 degrees. Okay? So this is actually going to equal 143 degrees. The reason being is if we treat 37 degrees as a reference angle, then 180 minus 37 is going to equal 143. Alright, and so angle C is 37 degrees, or angle C is 140 degrees. Therefore, angle ACB, remember this refers to angle C, is 37 degrees or 143 degrees. Let's give you a little bit of time to catch up on this and just kind of think about what you just did while I drink my coffee. Step 4, determine the measure of angle BAC. Okay, so if we're looking for angle BAC, that is going to be this angle on both of our triangles, okay? So that's angle A. Now, there are easy ways to do this than calculating it out. We can just go, let's do red triangle first. So on my red triangle, this is where you have to use your logical reasoning. Okay, you know that for red triangle, if this is acute, then this is going to be obtuse in this case. Okay, because it's over 90 degrees. And so I'm using my angles 180 degrees minus 37 degrees minus 30 degrees, and that'll give you 113 degrees. And now let's look at our blue triangle. Okay, so we know that this, we'll call that A1, is 113 degrees. Now, my little triangle, that is a really small angle. If you look at the angle it's making, it's going to be, looks like it's going to be less than 10. And so if I have 180 degrees minus 30 degrees minus 143 degrees, because this was 140 degrees up here, 143 degrees up there, so that is going to be 7 degrees. And so the question initially was to determine the measure of angle BAC. Okay, and so if we look at this, then we have two solutions to this problem. Angle ABC was, or sorry, BAC, angle BAC was equal to 7 degrees or 113 degrees. Okay, and so again, we had an ambiguous case right there. Now, let's look at case number 2. So again, we want to start by sketching a rough diagram in this section here. Now remember, I'm going to do this one in black actually. So remember, I said before you actually put this measurement of 4 centimeters in, it's best if we extend this line over here. Okay, and the reason is that'll give us more room and to actually work with making this this other side of 4 centimeters. Okay, so now let's put in 4 centimeters. All right, I can't put 4 centimeters anywhere in here because it'll just be too big. And so if still like 4 centimeters I know is going to be over here. Okay, so 4 centimeters is going to be almost right where I ended that line. Just got lucky there. Okay, so 4 centimeters. Wow. Nice triangle. Okay, and so this is going to be side C right there. Now, that's step 1, is sketch the rough diagram below of my triangle 4 centimeters. And now we need to use the sine law to determine sine of C. Okay, so we are looking for what this angle here is. And so let's set up our triangle. We have sine C, we have side C, and we have side B right here. Okay, which was 4 centimeters and 3 centimeters respectively. So sine C is unknown, but we have side C, which is 3, and we have sine B, which is 30 degrees, and we're going to divide this by side B, which is 4 centimeters. Sorry about that. I just had to pause for a second there. Okay, let's continue on this question. So now the next thing we're going to have to do is rearrange this. Now remember, you are just cross multiplying from this point on. I noticed on the quiz there were people having difficulties with that still. Okay, so what this is going to look like is going to be 4 sine C is equal to 3 sine 30. And then you're going to divide both sides by 4 to get the sine C by itself. Divide that side by 4. So sine C is going to equal to 3 sine 30 divided by 4. And in your calculator, you should get an answer of 0.375. Okay, so now, step 3, solve for sine 3, or sine c is equal to, I found that to be 0.375. Alright, so let's throw that into our calculator. So inverse sine of 0.375 and 22.02. Remember, round to 22 degrees. So angle C is 22 degrees, which means angle ACB is 22 degrees. Alright, ACB, you're always looking for that angle in the middle if it's notated this way. Alright, so now we need to determine the measure of angle BAC. Now BAC is going to be this angle right here. Okay, we know what this angle is. We now know what this angle is, 22 degrees. We can now solve this. 180 minus 30 minus 22 degrees is going to give us 128 degrees. And so state the solution to the problem. Now when you're outlining the solutions, make sure you use this notation. So if you're solving for angle A, you're going to use the notation BAC. Okay, so angle BAC is equal to 128 degrees. Alright, so that is the final answer. Okay, so let's look at case number 3 now, where AC was over here. We have to make that equal 1 centimeter. So again, first place to start is by extending this opposite side of our triangle. Now we need to make this 1 centimeter. 1 centimeter. Okay, and so if you can see my ruler right here, you'll notice that this is 1 centimeter right here. And there's no way that I can make this 1 centimeter actually close my triangle. Okay, and so I'm going to try. Bam. 1 centimeter, where's that? Bam. Okay, so I'm going to come up short here. Okay, so if I'm coming up short here, then there's not actually going to be a solution because there's no angle formed at this point, right? If I look at what I have here, there's no angle formed because the triangle, it's not actually a triangle. And so when you have a situation like this, then there's no reference angle, right? Like if I'm looking for angle C, so this would be side C, that's where the triangle terminates. There's no reference angle because there's no angle formed. So for a question like this, we would just write no solution. Okay, so there's no solution there because there is no reference angle. No solution, you could say no reference angle. So that's all we have to do for that question. Now let's look at what we just learned, okay? Now let's take a look back at case number 1. So with case number 1, we had how many solutions? We had 2 solutions, right? 7 degrees or 113 degrees. This is the one where we had the small triangle and the much bigger triangle. Okay, and so we had 2 solutions here, but let's see what we actually had. We found our reference angle to be 37 degrees. Okay, so reference angle was equal to 37 degrees. And if we look at our given angle was 30 degrees. Now, if we have a situation like this where our reference angle is greater than our given angle, then there is going to be 2 solutions. Okay, so if your reference angle is greater than your given angle, there's going to be 2 solutions. Now let's look at what happened with case number 2. With case number 2, we only had one solution, 128 degrees. So let's look what happened with our reference angle though. Our reference angle was 22 degrees and our given angle was again 30 degrees. But what that tells us is that our reference angle was less than our given angle, and so there was only one solution. And in that final case, case number 3, there was no reference angle. So if there's no reference angle, then there's no solution. Okay, so let's fill in the conditions for the ambiguous case of the sine law. If the reference angle is greater than the given angle, there will be how many solutions? 2. Okay, so our reference angle is greater than the given angle, there's 2 solutions. If the reference angle is less than the given angle, there will be 1 solution. And again, if the reference angle does not exist, there will be 0 solutions. Okay? All right. Okay, so I've decided to go over this note part just because it's going to be helpful for the next 2 examples and the last 2 examples. Okay, so in the case of B above, what this is referring to is this question, case 2 right here. So it's saying where the angle of reference, angle C, is less than the given angle. So remember that we had a reference angle in this case of 22 and a given angle of 30. Okay? And so if this is the case, then another thing we know is that our side B will be greater than side C. And so if that's your case too, then there's going to be 1 solution. Okay, so if the side opposite the given angle is greater than the side opposite the required angle, there's only 1 solution to the problem. Okay, so what that means, if the side opposite, I'm going to bring this example back in the page. Okay, so you don't have to flip over your book. If the side opposite your given angle, which was 4 centimeters, is greater than the side opposite of your reference angle, which was 3 centimeters, then there is 1 solution. Okay, so I'll say that again. Our given angle was B, and the side opposite of our given angle is 4 centimeters. Our reference angle was C, which was 22 degrees, and the side opposite of that is 3. And so 4 is greater than 3. Okay, so this side opposite the given is greater than the side opposite of the reference. Then there's 1 solution. Okay, now if the side opposite the given angle is less than the side opposite the required angle, there are either 2 solutions or no solutions, depending on the height. Okay, so that's referring to this triangle here, where we had 2.5, that's opposite our given angle. It's less than the side opposite of our reference angle, which was 3. And so if it's the other way around, there's either 2 solutions, or in that case where we had a side of 1 centimeter, then there are no solutions. Okay? And so, our last 2 examples. Without using the sine law, determine in which of the following cases there is exactly 1 solution to the problem. So there is 1 triangle which can be constructed from the given information. Okay, so calculate angle C in triangle ABC, where angle B is 56 degrees, C is 10 centimeters, and B is 12 centimeters. And so right away, if I look at this, then I know that this triangle is going to be really big to fit on my page. All right, now I am still going to draw it just to kind of show you what this is saying, but I'm going to scale it down a little bit. So I'm going to scale it down by a factor of 2, which means that this would be 5 centimeters. And here we have 6 centimeters. Okay, so the next thing you need to do is just determine where that 6 centimeters is and where that 5 centimeters is. Now, if we set up our triangles like the last few ones, then I know that if I have C, that's the opposite of angle C, which is our reference angle, which was up top. And so C is going to be on the bottom, which means that I will have 5 on the bottom here. Okay, I also know that angle B would be down here, and that's 56 degrees. Okay, so let's go ahead and draw this angle, which will be 56 degrees. 55, 56 will be about there. And I can draw this angle to connect down here. And so I'm going to go off my page a little bit, but that's fine. Okay, and so now I know that this is however long that's going to be, but this angle here is going to be 56. Okay, and this side was 5 centimeters, but remember this 5 was equal to 10 centimeters. Okay, just because I scaled it down. Now, the 6 centimeters has to fit in somewhere up here, which means that, well, I'm going to have to continue going up a lot further. But I know that this side over here is going to be 6 centimeters. Eventually, it will connect. All right, and so I know that 6 is greater than 5. So the side opposite my given angle is greater than the side opposite of my reference angle, which would be C. That's B, and that's A. And so we have to take a look back at our information. So if the side opposite the given angle is greater, then there's going to be one solution. Okay, so we can say that there's exactly one solution because we were following those previous rules, which said that if the side opposite my given angle is greater than the side opposite my reference angle, and so since 6 is greater than 5, we have one solution. Okay? Now let's look at this next one. If we have triangle QP, or calculate PQR in PQR, where in triangle PQR, where angle QPR is 41 degrees, RQ is 3 centimeters, and PR is 4.2 centimeters. Okay, so again, this is one of those times where it's probably best if we actually make this triangle. Okay, so if we were to make this triangle PQR, then I'm going to set it up kind of the same way that I've been setting up the other ones. All right, so it's going to look a lot like this one over on this side, but with different dimensions. So if we have PQR, I'm going to call, let's say RQ. RQ I'm going to call the base, and no, PR I'll call the base. And that's 4.2 roughly. Okay, so that's 4.2 centimeters, and I know that this has to be 41 degrees. So 41 degrees there, and like that. Okay, so this was P angle, or no, this is R, this is P, and this is Q. All right, and so we know that QPR is 41 degrees. So PQR, that's the triangle that we have. And RQ is 3 centimeters. And so R to Q has to be 3 centimeters, which means that we're actually going to be right about here. So 3 centimeters. Now, we're not actually looking for any angles, but we just need to know what these angles mean. Okay, so this was RQ, this is RP. Now, remember, if our side given opposite the given angle, 41 degrees, is less than the side opposite the reference angle. This is my reference angle here. Let's call that theta. So now I don't exactly have one solution. All right, because this side is greater than this side. And this is the side opposite of my given angle. This is the side opposite my reference angle. Okay, so if the side opposite the reference angle is greater than the side opposite your given angle, then there's not exactly one solution. Okay, so I'm just going to say not exactly one solution. Okay, and so those are the two answers for the second example. Now again, we don't actually have to go through the process of solving using sine law. We could, but we don't have to do it in order to know that there's one solution or two solutions or no solutions. Okay, now let's look at the last example. Find all possible measures of angle C in the following triangles. So triangle ABC, where angle A is 50 degrees, side A is 7.5 degrees, and side C is 9.5 centimeters. 7.5 centimeters and 9.5 centimeters. Okay, so again, we could go through this process of drawing up our triangle, but I'm not going to do that this time, and the reason being is I want you to be able to solve these questions quickly. And if you're always drawing triangles, that might take you a bit longer. And so since I know that I have three pieces of information for this triangle. I have angle A, I have side A, and I have side C. Okay, and so I can right away use my sine law. And since I don't have any measurements for B, I'm not going to use B, but I'm going to use sine A over A is equal to sine C over C. And so we're looking for all possible measures of C, angle C, in these questions. Okay, and so let's see what we're going to have set up here. We're going to have sine A, which was 50 degrees, sine 50 degrees divided by A, which was 7.5 centimeters. We're looking for angle C, which was our unknown, and that's divided by 9.5 centimeters. Okay, and so now all we need to do is set this up by cross multiplying. And so we are going to have 7.5 times sine C is equal to 9.5 sine 50. Alright, and then I'm going to solve for sine C, which is equal to 9.5 times sine 50 divided by 7.5. And when we type this into our calculator, you're going to get an answer of 0.9703. And then let's find out what that reference angle is. 0.9703. 76 degrees. Okay, so angle, and that's the reference angle for C, is 76 degrees. Okay, now that's our reference angle. Now, if we look at our earlier rules, our given angle is 50 degrees. Our reference angle is 76 degrees. So since our reference angle, okay, so reference angle is greater than our given angle, there are two solutions. Okay, the reason I know that is because we specified this earlier. There are two solutions. So we know that one of them is going to be 76 degrees, and the other one is going to be 180 degrees minus 76 degrees, and then the other one will be 104 degrees. Okay, so these are our two solutions, are 76 and 104. Okay, now let's do this last example. So triangle ABC, where angle A is 50 degrees, A is equal to 9.5 centimeters, and C is equal to 7.5 centimeters. Okay, so let's set this up. We don't need anything for B, and so I'm gonna do this shorthand this time, okay? So sine C over sine A over A. We're solving for sine C, which means that we're gonna have sine C over C, which is 7.5 centimeters, and sine A, which was 50 over 9.5. Okay, and so if I do the shorthand, sine C is going to equal, cross multiply these two, 7.5 times sine 50. To solve for sine C, we'll divide that by 9.5. Sine C is equal to 0.6047. And if we find out what that reference angle is, 0.6047, we get an answer of 37 degrees. 37 degrees. Now, our reference angle is less than our given angle, therefore there is one solution. Okay, so reference angle is less than given angle, therefore one solution of 37 degrees.